I looked at a bunch of names as people popped in. It's really cool because, I mean, it looks like talking to a bunch of friends, and that's great. So I'm going to try to run through this pretty quick, maybe about 30 minutes or so, and then hopefully plenty of time to have an interesting discussion. A couple of acknowledgments when I get started. I don't know if Clay Arango popped in, but good friend and colleague, he sort of prompted me to work together with him to put together a climate change talk a couple of years ago for the museum on campus. So thanks to Clay, I probably stole some of his slides. Also, I'll be showing several pictures, and I've got a ton of pictures, but I have no idea who took a lot of these. So thank you for your picture. I probably didn't put a photo credit, I'm sorry. But anyway, let's see. I think I'll move on and give you guys a quick, come on. Here we go. Okay, quick overview. We could do a whole speaker series just on climate change effects, but I'm just going to really do a quick overview on some climate model predictions for our area, then talk about potential impacts in the watershed, and then, finally, what should we do about it? And that's where you guys can come in and tell me what you think. So no surprise here. I mean, you guys have probably seen this many times, this idea of CO2 levels. When I started teaching at Central, it was back here. I remember teaching ecology saying, gosh, we might see 375 parts per million or even 400. Yeah, that's what it was on Monday. And because of that, yeah, we see this huge increase in global temperatures, right? These are, I believe these are 20-year bands. So the band with the dots is 2020. It's the hottest on record. And I'm assuming 2040 will be up here too. A couple of information items. There's the latest issue of Scientific American, if you guys can get that, really good article by Bill Ripple and a group at Oregon State. This sort of summarizes where we are and why it really is a climate emergency. We're also lucky, here in the Northwest to have this climate impacts group at University of Washington. So go to their website. They've got a lot of great information, reports, and I took a lot of their information to put some of these models together. So one of the things that they did out of that climate impacts group is, they've got so much data and so much modeling they've done. But one of the things they've done is put together these scenarios, B1 and 1AB. And so if we look at temperature change up through the end of the century, the B1 scenario means that if we can continue to make some, environmental changes, but really with no major global climate policies, so in other words, no Paris Accord, none of this, we're going to be in B1, which would be the yellow line. There's a lot of error in here. This is temperature rising. But if we continue the economic growth that we've seen, especially in the Pacific Northwest, and we continue to use fossil fuels along with hydropower and solar and wind, we're going to be in the red line, which is the 1AB, and it's much, much hotter. With precipitation on those two, we're looking at either way a rise in precipitation. The reason there's so much air in these models is because, as you know, parts of the Northwest are really wet and parts are really dry, so there's a lot of error in trying to predict precipitation. One of the reports that they came out was this one last year or the year before, shifting snow lines and shorelines. And of course, they show the relationship between CO2 and temperature, no surprise. But there's this interesting little graphic in there that shows, for the past about 60 years, 30% drop in snowpack, more than half reduction in glaciers, sea levels rising here and warming and getting more acidified. And then this, which has already happened, and it's going to continue to happen, that the peak stream flows have moved earlier, 20 days earlier, according to some of theirs. So those of you that have been in this basin for a few years, let's remember back in 2015, this is an image that was taken of the Cascade snowpack in mid-May 2014, and then early May in 2015, the next year, a lot less snow. And you remember what that was like. We went into emergency mode to save fish, to do anything we could. Agriculture was pretty desperate, so that was a bad situation. And a few years after that, there was this federal report on climate assessment for the Northwest. And I don't expect you to read all this, all the words here, but basically because of what happened in 2015, they came up with these 5 key messages, all of which, are pretty dire. I mean, bad things happened, as you know. Unfortunately, the predictions are 2015 wasn't weird. I mean, we maybe see 2015s a lot more regularly in the future. Okay, let's zoom into where we all, well, I was gonna say all of us, not all of us, most of us live in this watershed, I think, on this talk. So you can probably pinpoint where you are right now. What's gonna happen, right? I mean, we're naturally wet along the mountains and then rain shadow, so dry here. So if we see changes in temperature and precipitation, a lot less snow, a lot more rain, the season's going to start earlier in the spring, and we're going to have a lot hotter and drier summers. And that's not everywhere, right? High elevations, low elevations, going to be very different. But overall, this is probably what's going to happen to the basin. We can look at an interesting data set from the Quinault River from the 20th century, early 1900s to late. What they saw there was a shift in much higher flows. This is a hydrograph in the winter and much lower flows in the summer. And the current models show that continuing into 2040, which is just 20 years from now. Huge drop in the amount of flow in the summer and much higher flows in the winter. And chances are that's what's going to happen here, right? Because less snowpack, our flows in our rivers are probably going to be much, much higher, probably higher than any of us can ever even imagine or have ever seen. And then the other extreme is by July and August, we may see really, really low, shallow, warm streams. And this is going to affect water quality. Yeah, it doesn't look great. Here's the teacup diagram that you guys probably are familiar with. This was pulled off on Monday. So we've got the 5 storage reservoirs, this one really less significant. Typically, right, the way we work is these fill in the spring, and then we start releasing water for water use, and then they kind of try to stay full because the reservoir that's not on this picture is this. Now, I don't mean this, I mean all this frozen water. That's a lot of water, and that gets metered out as it slowly melts throughout the summer, and that's what then keeps these. Well, if we don't have this, or we keep getting less and less of this, these reservoirs may be filled in the winter, and then when they start draining, they're draining. There's no refilling them, and that's an issue. So I'm going to focus on 2 species that most of you know really well, cutthroat and bull trout. The reason I'm picking these are highly sensitive to water temperature. Interestingly, these are pretty widespread, and yet, as far as I know, there's no monitoring of cutthroat populations in streams, certainly not in the Yakima, and I don't even know throughout their range if there's much monitoring. We are monitoring bull trout by looking at their redds or their spawning nests, and this simple graph just shows in the Natchez and Upper Tieton, the populations are doing fairly well compared to the Upper Yakima. These populations are just barely hanging on. And if anything happens to these, then we're in real trouble because all above dams with no fish passage, that's an issue. I'm going to show a few images of maps pretty quickly here. This came from Dan Isaac and his group at the Rocky Mountain Research Station. He's done a ton of work on stream temperature modeling. So this graph shows, or this map shows, the likelihood of where we find bull trout, all life stages, and their probability. And if you look way up in the upper right, you might see that this shows with 0 brook trout. Brook trout are non-native, and they compete directly with bull trout. So where there are bull trout or brook trout, bull trout usually lose out. And so this was the distribution. The darker blues means a higher probability of occupancy, and then yellow is less and red is even farther less. So This was in the 1980s. If we fast forward and say, okay, the way temperatures have been rising, what are these patterns going to look like in 2040? And we see a lot less blue throughout the distribution. If you want to focus in on the Yakima here, boy, we went from a lot of blue to a lot of yellow and red. And then we go ahead to 40 more years in 2080. And wow, you know, according to the current rise in temperatures, it doesn't look good at all for bull trout in the entire basin. If we look at cutthroat trout, it's much more widespread distribution, but the same, you know, and again, this is a best case scenario, imagining that there's no brook trout. Well, we know there are brook trout that compete, but if there were no brook trout, the same thing. Look at the pattern here in the Yakima. They're confined to the upper mountain streams. 2040, we get fewer populations. 2080, again, boy, low probability that we see. And that's, I mean, that's the prediction based on current rise in stream temperatures. So I don't think any of us want to see this. So maintaining stream temperatures the way they are now and don't letting them get to where it is showing here in 2040 and 80 is important. All right, back to these models, right? This B1 and A1B scenarios. This image on the left, I want you to focus on, if you will. This is precipitation. So if we classify watersheds based on their dominant precipitation, right? Blue here is snow dominant, and then the red is sort of a transition, snow and rain, and then mostly rain for the green. So if we look at either one of these, you know, if you want to focus on the Yakima again, and we jump from where we are today, right now, you know, the Yakima is in a transition where we have rain and snow. You know, as we move through 2040 and 2080, boy, we get to where it's almost all rain. Well, what does that mean when we don't have as much snowpack? So I want to now shift to talking specifically about salmon and how this change in precipitation and stream flows and changing hydrograph might potentially affect them. So most of you know that salmon eggs and their development is purely temperature driven. So as we see temperatures rise and the regime change in water temperatures, that's going to affect their development. The salmon that rear in small streams or side channels of larger rivers are going to be affected because those temperatures could rise. The low flows may affect a lot of the movements. Some of these may even get above 25C, which means, you know, that's going to be close to the lethal zone. And there may be some oxygen problems depending on, you know, what river and how many nutrients are being added in there. So here's just a hypothetical situation, just kind of to illustrate an issue. This is a hydrograph, and I kind of roughly took this from, if you're familiar with the basin, the American River up in the upper Natchez. In that river, it's natural, there's no regulated flow, so we see typical May, June high flows, and then September, October low flows. So if we do see this shift, which is what all the models are predicting, that we're going to see that peak flow move to February and March now instead of May, June. Well, what does that do to salmon? And I'm going to specifically mention spring Chinook salmon. So spring Chinook, right? They're called spring Chinook because they run up the river in the spring. And they would go up to the American River, usually maybe May, late May, early June. And then they would just find big pools and hold until they spawn. Well, they can access a lot of these places because the flows are high and they can get to those. If the flows, let's say at the end of May now, are going to be closer to this level instead of this level, you know, that could cause some passage problems. Once they start spawning in August and then the eggs are developing, if the temperatures are warmer because the flows are so low, we might see much more rapid development and hatching. Typically, these things would hatch in January or February and then emerge from the gravel as larvae in the spring. Well, if that happens and these things are emerging from the gravel at peak flows, boy, we might see some massive die-offs of these little larvae because they certainly can't swim very well. We then get juveniles. If they can survive that, then they're going to be inhabiting the stream during the low flow period, midsummer on. And so I think this is probably our critical period, right? I mean, this is where we get that entire next generation after a few years in the ocean. You know, if we lose this life stage, then, you know, we're in serious trouble with trying to maintain runs of spring Chinook salmon. The other thing that can happen, right, is, and unfortunately, you guys have probably all seen this, late summer, I mean, it's predictable in certain streams, we're going to see isolated pools and braided areas that are just going to get really warm because there's no shading here. And fortunately, a lot of people, including a bunch of you guys at Mid-Columbia Fisheries, have been great about, you know, jumping in and coordinating efforts to rescue fish out of these. Sometimes you get to a pool and you're too late and you find, you know, fish that are just recently dewatered. Or if you even get to some of these pools and there's no fish left, you know, maybe it's because the predators had such an easy time, like this garter snake, getting to these fishes. So, you know, this is a real issue when we start seeing these generations of salmon being isolated and decimated in these isolated pools. Okay, now let me just shift and talk about the whole fish community in the entire basin, right? I mean, if you want to look at the health of a river, looking at the whole fish community is kind of a good way to get a handle on how healthy is the whole river basin. So currently, we have about 47 species of fish in the Yakima Basin, 29 native, about 18 non-native. This number is probably growing. And so I'd like to start up high and talk about the fish community and work our way down. If we start in the headwaters, right, where we've got these nice shaded high gradient tributaries with large substrate, if you go to those areas, right, all these tributaries up here, we're likely to find populations of cutthroat trout, populations of bull trout, mostly juvenile bull trout, cedar sculpin. They're going to be in almost all these streams, and then a few are going to have the introduced non-native brook trout. These are all cold water adapted, and you know, this is what we'd find today. Most of these would be here. Now we move downstream. So, you know, imagine the main stem Natchez or Yakima. Substrate starts to change. We get smaller substrate, cobbles, gravels, a lot more wood, side channels, deep pools, riffles, a lot more diversity of habitat. And because of that, we see a lot more diversity of fishes. So now I'm talking about, you know, like main stem Natchez, main stem Yakima here. And if we look at the fish community here, now we see several different species of cyprinids, right? Several different minnow species, sticklebacks, a couple of native suckers, larger rainbow trout, whitefish, some juvenile salmon, lampreys, and we start picking up these non-natives like centrarchids or the sunfishes. And now we move all the way down, let's say below Prosser, you know, towards Tri-Cities. So this reach down through here, right? This has changed so much. And again, I'm not telling you anything you probably don't know. Water's much warmer. The flow has been reduced. So many more nutrients have been added. So much more fine sediment. The conditions have totally changed from a typical Northwest river. That now, if we look at the fish community, the biomass is dominated by smallmouth bass, carp, channel catfish. I mean, there are bullfrogs down there. I mean, there's still pike minnow that's a native cyprinid. But I'm concerned that if what happened in this lower reach with warm temperatures, lower flows, more nutrients and sediment, if that starts to change as we move upstream, I mean, are we going to see the fish community turn into a catfish, bass, carp community here? You know, that would be a real troubling sign that something's really, really wrong. Okay. back to the models. Talked about precipitation, right? Let's look at the right side of this now. This is flood occurrence. So the way to kind of view these, again, these two possible scenarios are looking at the circles. And again, let's focus in on the central Washington area here, right? The larger the circle and the darker red the circle, that's more intensity or more frequency of flooding. And just a couple of years ago, you may remember, if you were in Ellensburg, the CW campus was flooded, the Cirque building and all the parking lots were flooded. I think this was taken down by Ringer Road, and the Yakima River came out of its banks there. This was down, I think this is 40th Avenue in Yakima. Yeah, that's Fred Meyer. A kind of minor, really. Well, it doesn't look minor, but really it is. It was more of an inconvenience, like, oh, parking lot's flooded, or oh, I have to wait days to get through the intersection. And this is not from the Yakima, but I found this picture somewhere, and I could just imagine that this could easily happen here, right? Okay, so an undersized culvert or a small bridge and just was eroded away and taken out, and a few vehicles lost. But imagine this is one of our county roads, and if this happens, it's not easy to just go in the next day and rebuild a road or a bridge. This could cause serious transportation issues with the infrastructure. And I'll bet you if we start looking at a lot of our county bridges and culverts, a lot of them are way undersized and are not expecting what could potentially happen. Okay, so flooding's going to increase. What about agriculture, right? This is a picture from 2014. This is one of the major reservoirs for storage irrigation water in California for their huge agriculture system. I mean, this was sort of like right in the middle or early in the growing season. If we see our reservoirs looking like this, let's say in June, then man, it doesn't look good. Now, if you're looking at agriculture water for Timothy hay and you're only concerned about a first cutting, that may not be that much affected. But the late season crops that need water throughout the growing season, apples, I mean, this is I'm pretty sure, our most valuable crop economically. And let's face it, this entire basin the economy is agriculture. And so, if we see the apple industry and orchards looking like this, that's some serious issues. If we start seeing grapes and vineyards dry up because there's just literally no water left in the reservoirs, and we know it's not going to rain in late summer. I mean, look at this horrible scene, right? An entire decimated hop field. If you're a wine drinker, this scares you. I like to drink good beer. This scares me. But I'm sorry. Look, I'm sorry to just for the past 20 minutes tell you how terrible everything is. It's not terrible. There have been so many good restoration efforts, and a lot of people that are listening right now are responsible for this. Adding wood to streams, that's a great thing to do. We're restoring streams around this basin. That's good. So the good news, we are replanting riparian areas to shade and cool streams. That's vital. I mean, that has to happen. Those are great efforts. The Yakima Nation, State Fish and Wildlife, everybody that's been involved with bringing salmon and steelhead back. I came to Ellensburg right about here, and it was really depressing. And I thought, wow, I can't believe that this is where we are. And then look what happened. I mean, things have really improved. Okay, 2015 was bad, and that's down here, and then they've been sort of down since. But this, tells us that we can restore salmon. We can restore the environment. I'm lucky enough, another example, to be involved with this I-90 ecological connectivity project. And it's a great thing to work on because we're seeing improvement. All these little shaded areas are places where the highway is now permeable, where it was a total barrier to gene flow from animals. And now we're seeing a lot of animals move. And so that's positive, man. That's good. That's happening. And there's dozens of other examples of positive things that are happening. There is a plan, right? It's not like we're just sitting around going, oh, bummer, there's going to be less water. What do we do? Well, there is this Yakima Basin integrated plan. And again, a lot of you are familiar with this. I'm sorry to show you this slide with all this little writing. I don't expect you to read any of this. I just wanted to show you this, that there is a plan. It's been funded. It's ongoing right now. There are a lot of good ideas on how to conserve water and make things better. I guess if I were to criticize this after looking at all the climate models and predictions, I don't know how much of the climate predictions went into this, because I believe this was put together given current situations, but I think we need to modify this thinking, well, what's going to happen in 2040 and what's going to happen in 2080, assuming these models are correct. Okay. Well, what do we do now? Yeah, you tell me, what should we do now? We've done some good things. And again, here's some crazy ideas, right? You want some ammunition for discussion. Yeah, here you go. Yeah, we need to keep restoring our riparian areas. These small streams are key. The headwater streams and small streams throughout the entire basin are key. Yes, we need to continue and way enhance and expand riparian restoration. What about rewilding parts of the basin? I mean, you all know the story of how wolves changed the entire Yellowstone ecosystem. Personally, I think we need hundreds and hundreds of more beaver colonies. I know it's not easy to transport and reestablish a beaver colony, but it's amazing what they can do with wetlands, and they do it without our help if we can just get them there. So that's a possibility. Boy, here's some controversy. We have to change our irrigation practices. Yeah, we need agriculture. That's what drives our economy. I get that. But really, if you say change Washington water laws, I mean, these laws are from the 1880s. They're archaic. It's ridiculous that we're living with these kind of water laws. Those have to change. I don't know how to do it, but we have to start making changes in the laws. It's ridiculous that we can allow somebody that says so on a piece of paper that they can dry up an entire stream. That just seems completely wrong to me. Forest management. I mean, we all saw what happened in California and Oregon this summer. So we need to really increase our forest management prescribed burns. I know we're doing that, but we need to do more of that. What about transportation infrastructure? Man, this is tricky. It's expensive. Look, here's an image I took off of Google Earth. So this is Kittisass Valley. This is Ellensburg. So here's the Yakima River, right, moving through. And this is Interstate 90. And Interstate 90 was built, this huge berm to build the interstate. It's built right through the middle of the floodplain. This river can't move. There's no side channels. There's very few off-channel habitats. This road needs to get out of here. But that's not easy. You don't just move an interstate. But these are tough decisions that we're going to have to make if we don't want to see the predictive models happen. So now I want to kind of wrap this up and ask you guys, what do you think we should do? I mean, there's things we can do individually, right? But I mean, collectively, the people that are listening to this right now are a bunch of really impressive minds. And I think we're lucky that we live in the Yakima Basin that has so many great groups with so many people that are passionate about, making things better. To show you that I wait to the last minute to put together a talk, look what was published today. This is an article. I mean, look at the author list. These are some pretty heavy hitters in conservation. And they, they lay out a really, really scary future for what's going to happen with species extinctions in our climate. So I don't want to, I'm just showing you that because you should go to this link and read this. But, I want to finish by saying we can we can see things get better. We already have seen things get better. We know that nature is amazingly powerful, and if we just give it a chance, it can come back. Let me finish, not getting too political, but let's face it, the facts are, we've all watched the last 4 years of, an environmental assault happening in our country, and looks like things are going to get better with the new administration. I think I just read today that starting next week, the powerful Senate Budget Committee is going to be chaired by Bernie Sanders. So that's positive. So look, if we see change happening politically, that's good. We already have people in place in this basin to do some great work. We just need to keep it up and expand it. So I think I'd like to just stop right there. Thanks to Becca and everyone at Mid-Columbia for inviting me and starting this series. And let's see if we can have a really cool discussion here for a few minutes before we have to finish. So thank you. I'll quit sharing my screen now.
Unmuted.
Thanks so much, Paul. That was really interesting and a really comprehensive overview in a really succinct time. So thank you. And since you did veer a little bit into politics at the end, I just want to balance that by saying we've been really fortunate in the Yakima Basin with the integrated plan and other recovery efforts because they have managed to bring together people from across the political spectrum. And we see bipartisan support for that plan that is focusing on providing water for agriculture and industry and fish and wildlife. It's one of the things I love about working where we do. That was great. Thank you so much. I would love to collect folks' questions. Go ahead and type in the chat, and then I can read those out and pass them on to Paul. And if we need a tickler, I took a screenshot of Paul's questions for us, and I'm wondering, what do people think about riparian restoration or rewilding, making changes to irrigation practices, changing the way that we manage our forests, or modifying transportation infrastructure?
Yeah, and I certainly don't have the answers, so please don't, hey, Paul, what should we do? I mean, I just think we should all start thinking about, okay, what should we do? Because we have to do something.
So Will, thanks for starting us off. We have a question that says, we definitely understand how beavers help with retaining water, but where do the wolves come in?
Well, I don't really know. I just know that what we've seen in Yellowstone, and this is also a question to everyone else. Do you think if we had more wolf packs in the Yakima Basin as a top predator, do you think that would change the behavior of a lot of the ungulates that we saw in Yellowstone? Do you think that would happen here, or is it such a different system that yes, we should bring back wolves because they're a natural part of the ecosystem, but would they affect streams and the flow? I don't really have an answer for that. What do you think?
Well, I saw, for instance, that Asia Woodrow is on this call. So if you were paying attention at the moment, Asia, would you mind jumping in on that? And in the meantime, Will, I can tell you what I have pulled together from the things I've read about Yellowstone, which is, as the wolves were reintroduced, they began to act as a check on the population of the ungulates, like Paul was saying, that were grazing the riparian areas. As the riparian areas were able to get a little bit denser, there was more opportunity for beavers to move in and colonize and make dams. So we started to see greater beaver activity that was related to the wolves. Now, wolves do eat beaver too, because beaver are the milk duds of the forest. But it seemed that there was a clear relation with the wolf reintroduction and starting to see streams functioning with increased beaver activity.
So far, I have not successfully unmuted anyone, so I'm not sure, just a small technical problem on my end.
You were actually, you were asking me to unmute myself, but I just kept saying no, so you're doing fine.
Well, I don't seem to be able to unmute Asia either.
If you don't mind, so on the wolf issue, and I get the wolf issue, but at the same time, like I'm a farmer, grew up in Idaho on a ranch and stuff, and we actually had wolves kill our cattle. And so I see the fine line of trying to bring wolves back, because I see that part of it. But at the same time, then we're also talking about possibly changing the irrigation laws or rules, or however you want to call it. So a lot of this that we're talking about, I feel that we also need to bring the agricultural people into this to kind of find that happy medium of irrigation, but at the same time we're bringing wolves back, so that it affects the ranchers. And so there's a lot of I get the environment issues and stuff, but there's a lot of issues where you're bringing up that I do feel that we should bring in other groups with agricultural experience as well, to try to figure out a happy medium for everybody.
Yeah, absolutely. And I think that's where we collectively, in this watershed, need to go. We need to get everyone together and say, oh, we're going to fight. There's not going to be enough water anyway. How can we solve this problem? Because it's going to affect every one of us. So no, it's not, it's not any group saying, hey, here's what we're going to do, and this is going to be better, and you're going to like it. Yeah, that's not going to get us anywhere. I don't really know the forum for that, but we can't just sit and wait for 2040 to happen. It's not going to look good.
Yeah, and let me just check in. So Bill Bosch sent out a link to an article about the wolf and changes to Yellowstone. Asia said that there is some conflicting science, that the case that's happening in Yellowstone is not quite as strong as it was when the initial news articles came out, which seems to so frequently be what happens. And then there was also a reminder that it's hard to make analogies between a system like Yellowstone and a more developed floodplain system like we have here. So I think the discussion is really valuable. And Paul, I would say that we do have some of those forums already existing in the basin. We do see those discussions happening through the integrated plan, through the recovery board, and other things. So, Will, I think as you get to explore your position more, you'll find that one thing we're really, really good at doing in this basin is congregating to talk about things. Okay, let's see. So Judy pointed out that she likes to think about the range of natural variability, that it's good to think of the full range of options instead of just counting some before we have fully explored them. Further up here, Bruce asked whether we could expand fencing along smaller streams that would prevent grazing from livestock species.
Yeah, I mean, I absolutely think, livestock need water. I don't think they care if it's in a stream or not. They need water and shade, I'm sure, but to have livestock just wandering through streams, we know is not a good idea, but that's a lot of fencing. But yeah, if we can keep the cattle out of the stream and keep them, watered and fed and growing, that's great.
And then Clay Arango, who's also a professor at Central, pointed out that sometimes our conservation efforts might be trying to return the basin to something that is a prior ecological state. And then he wonders whether that's going to be sustainable in the future changed conditions. So he asks, to what extent are conservation efforts trying to anticipate a future climate changed ecological condition? I know the questions are for Paul, but I like to talk. That is something that our grantors are very tuned into. And so as project sponsors are proposing restoration projects and seeking grant funding, we need to be demonstrating how our projects are being responsive to modeled changes in conditions. So we are frequently thinking about how they will help our ecosystems to be more resilient to flashier hydrographs, getting more of the precipitation as rain and less as snow, and warmer conditions. So at least on the scale of how we're developing restoration projects, that is very much in consideration. Did you want to add anything to that, Paul? Because people are throwing questions fast and furious. I'm going to keep going otherwise.
No, I totally agree that It doesn't make sense to think, oh, we need to go back to, 1820 conditions. We just have to adapt to conditions now. And it's going to be tough to kind of pick and choose which ones have a high probability of success and that we can afford. Yeah, that's not easy, but yeah, absolutely. We have to be realistic about the way the conditions are now, and that we will continue to have agriculture. We need that. And we need salmon, and we need clean water. And so, yeah, if this was easy, we would have already had a plan and working on it. So, but besides questions, how about people throwing in some answers for us to talk about?
Okay, well, Joel Hubble has a little bit of an answer. So he points out that to offset the loss of snowpack, which is a million acre feet on average, we will need more storage to catch water that now runs off in the spring that would be running off in winter instead. And also that improved forest health will help slow down spring snow melt. Tom, I saw that you had 2 comments, but they didn't show up here for me. Do you want to try putting them in again, or Sam?
I got to say, I
Yeah.
always forget that when I hit enter, it enters the comments rather than just start another line. Yeah, just 2 things real quick. One for Will is the 2 entities that were really responsible for starting the process of the integrated plan were the Rosa Irrigation District and the Yakima Nation. So irrigation has had an equal part in establishing the integrated plan as the tribe or anybody else. And the second thing is that the storage options in the integrated plan were run through the climate change scenarios. As a comment for Paul about how they're going to work in climate change. That has been analyzed. The documents are on the Bureau webpage. And for a lot of us who were not fans of headwater storage, given the damage that headwater storage had done to the hydrograph, particularly in the upper Yakima, it became really clear that with years like 2015, if the problem is we're losing headwater storage due to snowpack, you have to store it somewhere. And so storage in reservoirs became a more viable option. So that's all.
Yeah, thanks, Tom. And I agree. It's like we have to store more water. We have to do that. I don't think anybody wants to say we need to build a whole ton of dams, but we have to store water somehow. I think beavers will help. That's not going to solve the whole problem. But yeah, maybe a lot of smaller storage facilities with fish passage, they can be done maybe a little more naturally instead of just square pieces of concrete. I think engineers need to be real creative in the future about how to store water.
Agreed.
Yeah, thank you. Okay, so Rhiannon asked, are there any programs that are currently monitoring in-stream thermal refuge as our temperatures rise? And we understand that increasing thermal refuge is an important part of riparian and stream restoration. Is there a mapping effort right now that's also looking at things like underground aquifers? Are there ways that we could increase in-stream thermal refuge as a way or as a means to create more resilient habitat for fish populations as temperatures rise?
Well, that's a great series of questions that I don't know the answers to. I don't know if there's a basin-wide effort to monitor stream temperatures for like subsurface flow hyperrheic temperatures. Tom, do you know any of this?
Probably not a basin-wide, but a ton of the work that Becca and others are doing are all about increasing surface water groundwater interactions, hyperrheic zone effectiveness. And I agree with you that beyond building reservoirs, recreating the natural storage mechanisms is really important, because they not only provide sustained flow like the flywheel on an engine, but they also moderated stream temperatures in a hot, dry place like the Yakima Basin. And the signature of global warming and the signature of watershed degradation look the same. I think, to a fish, flashier runoff and warmer stream temperatures. So the antidote is basically restoring that thermal moderation. There's been a lot of work done in the lower river that I think Becca knows about, and Benton County Conservation District is working on, because that's obviously the worst place for temperatures in the basin.
Yeah, I think when we think about a large scale effort, it's really been in the lower Yakima, where the Bureau of Reclamation flew infrared flight in 1997 in August that picked up areas where there was cool water input into the river. And then Benton Conservation District, with support from the integrated plan, just flew that again this past August, so in August of 2020. Benton Conservation District has also led floats through the river with thermometers pulled behind the canoes. A very fun gig, by the way, if you're looking for fun field work, where we were able to pick up where there were patches of cool water coming in. So there's really good refuge mapping for the lower part of the Yakima watershed, and I don't think we've done anything nearly as broad scale as we move up above Union Gap. Okay, so Kat Satnick pointed out that when we're thinking about storage, we should be thinking about managed aquifer recharge also, not just above ground storage. Thanks, Kat. Asia sent us a link for how forest thinning can be used to hold on to snowpack. That's really interesting work if folks haven't delved into that at all. I was just pointing it out to my kids when we were hiking the other day, like, look how there's snow here and look how there's not snow here. It's another good opportunity to go see that in the field. And then Gabe Temple pointed out that there have been cold water refuge studies done pretty comprehensively on the main stem Columbia. So a lot of the work that we're doing for cold water refuge on the lower Yakima is based on work that USGS and others and EPA have done on the Columbia. Really good thoughts, folks. Thank you. I just talked through all of those, Paul. I forgot to ask you if you wanted to address any of them. Sorry.
Oh, that's great.
Okay, scrolling back. So we're coming at the end of our time. You know, the one question that I had, Paul, as we went through, I really appreciated your chart of life stages and changed hydrograph and the emphasis on juvenile rearing and the changes we expect to see there. What would you do as the top priorities for restoration work if we're trying to increase the suitability of these change systems for juvenile rearing?
Well, you know, we don't have any control over the precipitation pattern. So what's going to happen is going to happen. So again, I think the more water that can be stored surface or subsurface through little reservoirs we build or beaver dam wetlands, that's going to sustain some of that flow. That's going to keep a lot of these small streams where some of these fish are going to have to rear. You know, I would also think that we have to increase, and I know we've started this, but side channel habitat is critical in a lot of these rivers. And if we can increase more of that, you know, the other thing is, you know, salmon are amazing. I mean, I can't believe they're still here after everything we've done. It's amazing we still have salmon runs. So they're incredibly adaptable, like all salmonids. And I think, you know, they will adapt. And if we can give them a few places that are still going to be cool and flowing, you know, they'll survive there. I don't have a great answer for this is what will happen.
Yeah.
Sorry.
No, but it's really valuable to go through the thought exercises. So thank you for leading us through that. And thanks to all who participated. Everybody brought forth really good ideas and questions, and I'm glad you were able to join us. I'll just pull up that schedule again so that we can remember that we have more opportunities to keep talking. Lamprey are a fish species that a lot of us know very little about. And so I'm excited for the opportunity to come together and learn more about lamprey and their role in traditional cultures and contemporary cultures, and then also what we could be doing to help lamprey survive. Margaret, I'll turn it to you to close us.
Thank you, everybody, for coming tonight. This was really great. I'm so pleased with the turnout and excited to get to see people from throughout our region, the Yakima Basin and beyond, down in the Columbia Gorge. Paula, I learned a ton, so thank you. And we're going to keep working on our tech. And if you had trouble with any of our registration or any of that, send me an email. I'll put my email address in the chat, or you can send it via Eventbrite. I'm curious how that works, since we have a bunch more to come and I want it to work for everybody. So thank you again for coming. Have a great evening.
Thanks, Paul.
Thanks,
Thank
guys.
you.
For everyone,
you.
keep up the good work. We've done well. Thanks, guys. See ya.
Thanks so much, Paul.
Bye.